Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the basics of systems and heat, calculation of heat. So a few things that we have to look at is some basic definitions. The system is the thing that we're studying. Okay? These are either reactions or solids that have been heated or whatever the case may be is a system. And then the system's enclosed by some sort of boundary, like the beaker here that you see, or it might be an invisible boundary. But once we get on the other side of that boundary, we now are in the surroundings. And when we talk collectively about the surroundings plus the system, that is called the universe. So there are three different types of systems that you should know. There's the open system, the closed system, and the isolated system. In the open system, you're able to exchange both heat and mass. This gas can be condensed into solid. So humans could be considered an open system, right? We take in mass and we also give out mass. And we can exchange heat through our skin. A closed system would be something that only can exchange heat. The mass is trapped inside. I put a lid on the beaker now so you can see the gas accumulating inside with the reaction taking place. Whereas an isolated system, it's been insulated and now there is no heat, there is no mass being transferred. It's, as the name implies, isolated. The amount of heat an object loses or gains is proportional to the amount of temperature change. And that proportionality constant would be referred to as the heat capacity. So here's Q. Q is the heat. Delta T is the final temperature minus the initial temperature. And when we look at the heat capacity, if we solve for C here, divide both sides by delta T, we can see the units would be heat, which is joules, over degrees Celsius, which is temperature. The formal definition of heat capacity is the amount of heat an object must absorb to increase the temperature of that object by 1 degree Celsius. Sometimes when mass is known, they might refer to a term called specific heat. Specific heat is the heat capacity per gram of substance. So if we have the C, which is heat capacity divided by the mass of the sample, that's what specific heat is. As a result, the joule per degree Celsius grams. And if we were to multiply both sides, we get a formula for the relationship between heat capacity and specific heat. So become familiar with these formulas. You might be given heat and temperature changes and asked to find heat capacity, or if they throw in mass as well, you might be asked to find specific heat, or you might be given specific heat and temperature asked to find heat given off or accepted. Remember, negative heat implies an exothermic reaction in which heat is given off to the surroundings, like these arrows. Whereas endothermic would be the arrows facing the other direction, where the heat is absorbed from the surroundings into the system. And I'll do separate videos for those as well. So hopefully I have clarified the foundations for this. You got to know these concepts in order to do bomb calorimetry, which will be one of the next topics I cover. So make sure you understand how to use both those formulas and the different systems. Hope I've clarified any doubts that you might have over the basics. Watch the example videos. Thank you and have a nice day.